Today I'm going to talk about string manipulation. So you can split that into two separate parts really, checking strings and transforming strings. So I'll start off with some basic string checks. So my string that I'm going to use for most of these examples is just going to be A, 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 B, 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 C, 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 C. And that should be good for most of the examples. So the first one to start with is checking the length. So to check the length of a string, you just use the length attribute. And we can say if the length is greater than 5, then let's print out some sort of eye-catching message match. And let's run that one. So this just counts the number of characters. Number of characters is actually 9, so we get a match. I'll change that to 10. No match. So that's length. And then the next most useful one would be equals operator. You shouldn't equals method. You shouldn't use double equals to test whether strings are equivalent. So if s equals a b b b b c c c c, let's just run that. And that works. And let's just for fun, let's see if the double equals works. This will probably work because strings are immutable, and the string literal a b b b c c c gets stored in the memory pool. So what you're actually testing here is the reference to the string. And this will say match. If, however, we did something slightly different, like string s2 equals new string, if we use this way to create a string, this will actually put it in a different memory location. So if I test whether s equals s2, if I run that one, then this should now fail. Yeah, so there's no match. But if you change it to the correct, if I did s dot equals so if I run that now, oh, it's complaining. What have I done wrong? If I see, I'm just missing a bracket there. Let's try again. So there we get the match. So that's, you should always use dot equals. That's a good demonstration of why you need to use equals, dot equals. Okay, so what else can we do? Starts with is always a useful one. If s dot starts with, and we can just put in our little character string here. We'll call it, if it starts with AAA, then we should get a match. There we go, that's our match. Another one that's useful is ends with. So I'll run that without ends with AA should be no match here. So we get no match. Let's just change it to CCC, and that should pass. There we go. We get a match. So that starts with, ends with. Then we could do is empty. Is empty if string s is empty. We don't need, there's no arguments to that one. So this will obviously fail. Should be no match. No, it's false. So I can negate that condition. I can say if it's not empty with the exclamation mark, and this should now come back true. Yeah, there's a match. So other stuff we can do is we can check the contents of the string. So we could say if s contains another string bbb. So let's run that. So this should come back with a match. Yep. So because this string contains bbb, and you can make it a little bit more sophisticated. You can use this thing matches. Now this allows you to put a regex. A regex is a whole different subject you can Google, but just a nice simple example is a wildcard. Dot star is wildcard in regex world. So you can do dot star, and you can do lots and lots of very sophisticated pattern matching using regexes. But this will just check whether the string BBB followed by any characters and preceded by any characters is contained within string S. Let's see if that works. There we go. So we get a match for that. And just to prove that it's, if I put an extra B in there, so has this string got 4 B's in? Let's just verify that this is actually working. So no, we don't get a match because there's only 3 B's in that string. Okay, so that's matches. And one last thing, one very useful thing is if you have, so if you've read in some data from a file, then you want to check whether this data, \n is just the new line character, end of line character. If you want to test whether this string that you've read in from multiple lines in a file contains that string, you'll find this doesn't actually work because the new lines confuse the s dot matches. So what you can do when you have a regex is you can precede it with this question mark s. Now this s has got nothing to do with the string s that I'm using in my examples here on line 6. It's just that this is regex notation. So this is telling the matches, the regex that I'm using in the matches method to ignore new lines. Now if I run it, we should get a match now. There we go, match. And then just to prove that it is working properly, if I put an extra B in there, we should get no match here. There we go, there's no match. So those are a quick tour of some of the sort of string checks you can do. Now the other thing I want to talk about is transformations. So let's start with nice simple one. So if we just go back to this string ABC, right? So we've got this string. So let's say s dot to uppercase. Always useful one. I'll print that one out. S. So as you can imagine, the to uppercase just transforms all the lowercase characters to uppercase, as you can see that. And conversely, you've got to lowercase, which does the opposite. Great. Now another useful one. Let's go back to our lowercase. Another useful one is trim. Now trim will get rid of we'll get rid of leading, carriage returns, and trailing spaces. So if I just comment out this for a moment, and we'll print this out just to show you what it looks like. So there we've got lots of space and carriage returns coming out here. Now if I trim it, you'll see it cleans up the string, so we get rid of all these carriage returns and spaces. There you go, quite handy. And okay, so what if we wanted to extract something from within the string? To do that, we need to use Substring, or Substring, I should say. So Substring, and the way it works is you take the character position where you want to start your extract, and the character position where you want to end it. So 3 is this character here, so that's where the first character is 0, 1, 2, 3, and then 4, 5, 6 is where you want to end. So the length of the string will be the final number minus the initial number. So it's character position 3 to character position 6 minus 1, if you like. Okay, so let's just demonstrate that. So this is going to print out BBB. There we go, BBB. Now there's all sorts of other stuff we can do with the format, the string format. So let's just have a quick go at this. So I'm going to do string dot format, and these are really old formatting things that go right back to C, all the C Unix days, but they all still work. So it's so if we wanted to, for instance, left pad a string with spaces, then we'd do so if we want to with a string that's well, let's say it's 10. No, we'll stick with 5, and I'll chop my string down. We want to lpad it to 5 spaces. So again, that S is nothing to do with the string itself. That just signifies that there's a string being supplied as a parameter. So that's going to left pad our string to 5 characters, and it might be useful to actually just put some chevrons around this string now so we can see what's going on. Let's run this. So there we go, you can see it's padded it to 5 characters, left padded to 5 characters. And we can, if we want to do an R pad, all we need to do is put a minus sign in there. You can Google all these formatting expressions, but these are just a few that are really handy to know. So if I run that again, then that should have right padded the string. There we go. And the other thing you might want to do is to create some fixed width text. So it's always 5 characters, for instance. So the way to do that is you do 5.5, sorry, with the minus at the beginning. And that will now give you a fixed 5. So for this example, it'll be the same as the previous one. So it's just made it 5 characters. But interestingly, if we now expand this, BBB, CCC, and run this again, you'll see it'll trim it. So it's just AAA, BB. Yeah, so it's just those 5 characters. So it'll restrict the width, it'll pad and restrict the width at the same time. Okay, a couple more things to run through. We can do a replace. So we can replace portions of the string within the string. So if I replaced BBB with XXX, then you'll see that that just drops in those 3 X's. Oh, missed a bracket, I think. Semicolon. There we go. So we've got those 3 X's in the middle there. Okay, the last thing I'm going to show you is replace all. Replace all is similar to replace, but it takes a regex here in the argument to the method. So one thing that's very useful is, again, so if you've read in some data from a file, then you might have tab characters. Let's just print this out just for fun. So if I just comment that, replace all that, and I'll just run this. So I've put a carriage return tab character. There you go. So you've got a character. It's all really messy. So to clean that up, what you can do is you can do this replace all, and it's a regex, so you can actually do something like this. You can do \n and then the or character, and then \t. So what we're saying is we're going to replace any tabs or carriage returns in the what have I done wrong? Oh yeah, we need to tell it what we want to replace it with. So we'll replace them with spaces, which is quite a safe thing to do. So if I now run this, there you go. So it's replaced all the duff characters, all the characters you don't want, with spaces, or you could just put an empty string there if you want it all crunched up together. So that's it. That's a quick tour of string manipulation in Java.